My dear students, today I am going to explain you one question from circle related to tangents. Question is two circles with radii R1 and R2 touch each other externally. Let R be the radius of a circle which touches these two circles as well as a common tangent to the two circles. Prove that 1 by square root under r equals to 1 by square root under r1 plus 1 by square root under r2. This is the diagram. This is the first circle in which radius is r1. That means you can say px is the radius. And this is the second circle in which radius is r2 and radius is yq, that is r2. And the third circle is this, which is touching the common tangent as well as these two circles. And these two circles, this smallest circle is touching at B and C respectively. And the radius of this smallish circle is RZ, that is a small r. Small r is the radius of this smallish circle. So the solution is here px equals to r1 and yq equals to r2 and rz equals to small r. So xy equals to r1 plus r2 and xs equals to px minus ps, that is equals to px minus yq, that is equals to r1 minus r2. And since psyq is a rectangle, because you see here ys parallel to rq has been drawn, or you can say that ys is perpendicular drawn on px, and since at point p radius is perpendicular because it is a common tangent, so radii are perpendicular on tangents, and that's why when we are drawing a perpendicular ys on px, sy and pq becomes parallel to each other. So psyq becomes a rectangle in which each angle is 90 degree and opposite sides are equal. So we are saying that PSYQ is a rectangle. This implies PS equals to YQ and PQ equals to YS. Now we are taking in triangle XYS. Angle XSY equals to 90 degree. So from the Pythagoras theorem, SY equals to PQ, that is equals to square root under XY square minus XS square, that is equals to square root under R1 plus R2 to the whole square minus R1 minus R2 to the whole square. And you know one formula, A square minus B square equals to A plus B into A minus B, and that's why we are writing here R1 plus R2 plus R1 minus R2 into R1 plus R2 minus R1 plus R2. Here plus became because here it is minus, and that's why this minus becomes plus. Now R2 and here R1 and R1 both are different positions, so it is being cancelled, so it becomes 2R2. And here minus R2 and plus R2 is cancelled, so R1 plus R1 becomes 2R1. So that is equals to square root under 2R1 into 2R2, that is equals to 2 is taken com. That means 2 and 2 into 2 square root is 2. So 2 is outside the square root and then inside it is R1 R2. So 2 into square root under R1 R2. Similarly, we can find out as we calculated here by drawing a perpendicular on px, ys we have drawn perpendicular. Similarly, we can do the same thing in smallest triangle also. So we can write PR equals to square root under 2, 2 into square root under R1 into R2, 2 into square root under R1R, and RQ equals to 2 into square root under R2. And then PQ equals to PR plus RQ. This implies 2 square root under R1 R2 equals to 2 square root under RR1 plus 2 square root under RR2. Now we are dividing both sides by 2. 2 will be cancelled, and then we are left with square root under R1 R2 equals to square root under RR1 plus square root under RR2. Now again we are dividing both sides by square root under R1 R2, and then we get square root under square root under R1 R2 by square root under R1 R2 equals to square root under R1 by square root under RR1 R2 plus square root under RR2 by square root under R1 R2. Now here this will be separated, and we can write here square root under R1 into square root under R2, and this will be separated as square root under R into square root under R1 into square root under R2, and here numerator and denominator both are same, it will be cancelled. R1 will be cancelled, then 1 by square root under R will be left here. Here also square root under R will be cancelled in the numerator denominator, square root under R1 will be cancelled, and then square root under R2 will be left. Yes, and in this case here square root under R cancelled, numerator denominator, square root under R2 will be cancelled, then square root under R1 will be left. So we are left with 1 by square root under R equals to 1 by square root under R2 plus 1 by square root under R1, and this implies 1 by square root under R is equals to 1 by square root under R1 plus 1 by square root under R2. That was only we have to do. Thank you. If you like, please share and subscribe.